Hi, Mr. Richards here. Today's lesson is on inequalities involving absolute value, and our objective is to solve and graph absolute value inequalities with the less than and greater than signs. If we focus on absolute value inequalities with the less than sign, the inequality, the absolute value of x is less than 2, means that the distance between x and 0 is less than 2. And if we look at that on a number line, we have 0, 1, and 2, and then -1 and -2. Well, if the distance is going to be less than 2 from 0, we can come out this way to 2, and we can go back this way to -2. So basically, x is going to be greater than -2, and x is going to be less than +2. So we can graph this on the number line, the circle at 2, or -2 and a circle at 2. We can graph this on the number line just being in between -2 and +2. So our solution here in that set builder notation would be for x, -2 is less than x, or x is greater than -2, and less than +2. Now, when solving absolute value inequalities, there are two cases to consider. Case 1 is when the expression inside the absolute value symbols is non-negative, and case 2 is when the expression inside the absolute value symbols is negative. Now the solution is the intersection of the solutions of the two, or of these two cases. Let's use that to solve some inequalities. So we'll solve each inequality, then graph the solution set. The absolute value of n minus 3 is less than or equal to 12. Well, we need to consider the two cases. Case 1 is going to be if n minus 3 is non-negative. And in this case, we'll solve simply n minus 3 is less than or equal to 12. Well, if we add the 3 to both sides, we will result in n is less than or equal to 15. Now, we need to consider case 2 as well, and case 2 is n minus 3 is negative. Well, if n minus 3 is negative, we have to assume that the negative n minus 3 is less than or equal to 12. We put this negative sign here. Now, I'm going to rewrite that to show our next step a little more clearly. We want to solve for n still. So our first step here, let's multiply by a negative 1 on both sides to kind of move that negative over, if you will. Now, that cancels out that negative there. And so you're just left with n minus 3 on the left side. And 12 times negative 1 is negative 12. However, since we multiplied by a negative number on both sides of the inequality, this reverses and becomes greater than or equal to. And now solve your inequality. Add 3 to both sides, and you result with n is greater than or equal to negative 9. So now we're looking for the intersection with the word and of n is less than or equal to 15 and n is greater than or equal to negative 9. And if I draw out my number line, and I have let's count by tens, I guess. Negative 10, negative 5, 0, 5, 10, and 15. I'm going to have closed circles, since I have the or equal to, at negative 9 and at 15. Now, we're looking for the intersection here. Now, n is less than or equal to 15 is everything going that way. And n is greater than or equal to negative 9 is everything going this way. So I'm looking for the intersection of these two. It's going to be in between the negative 9 and the 15. And that's my graph. So again, to write this in set builder notation, I will have, for all numbers n, negative 9 is less than or equal to n, or when n is greater than or equal to negative 9, and when n is less than or equal to 15. And that's my solution. So once again, we'll solve this inequality and graph the solution set if we can. The absolute value of x plus 6 is less than negative 8. But here's the thing. The absolute value of x plus 6, it cannot be negative. I mean, there's no number you can put in for x that's going to cause x plus 6 to be negative 8. So, it is not possible for the absolute value of x plus 6 to be less than negative 8. Therefore, there is no solution, and the solution set is the empty set, which again we'll just write as kind of a big oval with a line through it. And that's it. Since we can't have the absolute value of anything be a negative number. Now, to apply these absolute value inequalities, let's look at the average annual rainfall in California. Now, over the last 100 years, the average annual rainfall in California is 23 inches. However, the annual rainfall can differ by 10 inches from the 100-year average. what is the range of the annual rainfall for California? I'm well aware that you could probably add 10 inches to the 23 and get 33 inches and subtract 10 inches from 23 and get 13 inches and come up with an inequality that way, but let's see if we can solve this using an inequality with absolute value. So let's create a variable here and call it x. And that x is going to be our average annual rainfall. Now, if we say something along the lines of the absolute value of x minus 23 is less than 10, well, the average rainfall minus that 23, which we got here, is less than the 10 degrees that it can differ. Then we can get into our two cases. We can get into case 1, where it is non-negative. So we can say x minus 23 is less than 10. Add 23 to both sides, and we would result in x is less than 33. So we'll have less than 33 inches of rain. And then we could do case 2, where x minus 23 is negative. And once again, we would then have the negative of x minus 23 is less than 10. And if we multiply by -1 on both sides, that cancels, and we're left with x minus 23. We have to reverse our inequality since we're multiplying by that negative number on both sides, -10, and then add 23 to both sides, and x is greater than 13. So we have x is greater than 13. We have x is less than 33. And to write this in our set builder notation, using compound inequalities again, for all numbers x, 13 is less than x, or x needs to be greater than 13, and less than 33. Now, as I look back at this question, I'm thinking, well, it can differ by 10 inches. Can it be exactly 10 inches? Sure. So actually looking back at all of these, you should probably all be or equal to's. There's nothing wrong with looking back and double checking that. So once again, I just made the correction here that these are going to be or equal to, since it can differ by exactly 10 inches. So that's that solution. Let's continue on. Now, what about absolute value inequalities that are greater than? Well, just like we did for the less than, let's look at the absolute value of x is greater than 2. Well, this means that the distance between x and 0 is greater than 2. And if we look at this on a number line, we have 0, 1, 2, 3, and -1, -2, -3. Our distances from 0 aren't going to be inside the 0 and 2 and -2. It's going to be on the outsides of it. We're looking for distances that are bigger than 2. So we're going to have actually open circles here at 2 and -2, and our distance from 0 isn't simply inside the 0 and 2 and 0 and -2. It's outside of it. We're looking for greater distances than 2 away from 0. So that's what our number line actually looks like. So x is going to be less than -2 or x is going to be greater than 2. So our solution set for this in set builder notation, x when x is less than negative 2 or when x is greater than 2. And just like the previous examples, we need to consider both of those cases. So case 1 is when the absolute value or rather the expressions inside the absolute value symbols is, in case 1, non-negative, and in case 2 is when it is negative. Let's see how these examples look. Solve each inequality, then graph the solution set. Let's first consider case 1, when 3y minus 3 is non-negative. So we can say 3y minus 3 is greater than 9, and add 3 to both sides. Cancels. 3y is greater than 12. Divide by 3, divide by 3, y is greater than 4. Now we can say, or, case 2, 3y minus 3 is negative. And once again, we'll put a negative outside the 3y minus 3, make that greater than 9. And again, let's multiply by negative 1 on both sides of the inequality here to cancel that negative out. So we're left with 3y minus 3, but we have to reverse the inequality, is less than negative 9. And now solve the inequality. Plus 3, plus 3. 3y is less than negative 6. Divide by 3, divide by 3, and y is less than negative 2. So we have the two inequalities. Y is greater than 4, and y is less than negative 2. To graph these, we have 0, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3. If we first graph y is greater than 4, we have an open circle at 4 and shading where y is greater than 4. And y is less than 2, or negative 2, an open circle at negative 2 where y is less than negative 2, and that's towards negative 3. And that's our graph. So in set builder notation, our answer here is when y is either less than negative 2 or y is greater than 4. And that's our solution. Now if we look to solve this inequality, again we need to look at the two cases. So case 1 is going to be when 2x plus 7 is non-negative. Now remember, when it was less than a negative number, we couldn't do much with it. But now that we are greater than a negative number, that's okay. We can actually do something here because we're saying, oh, it could be a positive number. So let's go through this problem and solve it and see what happens. We would have 2x plus 7 is greater than negative 11. Subtract 7 from both sides. We have 2x is greater than negative 18. Divide by 2, divide by 2, and x is greater than negative 9. So any number that x is greater than negative 9 will work for that inequality. What about case 2? When 2x plus 7 is negative. Well, in this case, we would have the negative of 2x plus 7 being greater than negative 11. And when we multiply by the negative 1 on both sides, that cancels, and we're left with 2x plus 7 is, reverse it, less than a positive 11. Subtract 7 from both sides. 2x is less than 4. Divide by 2, divide by 2, and x is less than 2. Now, our greater than are our ors. So when we go to graph this, we consider negative 9, negative 8, negative 7, negative 6, negative 5, 4, 3, 2, 1, 0, 1, 2. When we consider this graph, x is greater than negative 9. Well, if I just sketch something above this, that's going to be everything this way. When I look at x is less than 2, open circle at 2, and everything this way. Now our key with the greater than symbol here with the inequalities is our word or. It could be x is greater than negative 9 or x is less than 2. And in this case, when you look for the union, it's actually going to be everything, all of them. So our solution here is actually quite special as well. This is going to be when x is a real number. So it's really any possible solution. Because remember, with our greater than, it's an or, it's the union. That's it for this lesson. Good luck.